board. Yeah, this board is fucking shit. Solder pad come off. This is the cheapest PCB and the bad quality PCB I ever work on. But maybe by the end of the video we're gonna make it work. Who knows? And this is the board that I'm afraid to work on it. And why? Because on my previous video, I'm gonna put the link on the description down below, when I was changing the capacitors, these traces, you just hit them barely and they're coming off like butter. Because this is what you get when you pay $2,500 or 1992 or 1995 for a high-end amplifier. You end up with a very cheap PCB, and also for the design. That one is from the manufacturer, components on the back side of the board. And yeah, we need to change some capacitors over here. And I hope I will not have the surprises to see the traces coming off from this board again, because it's a nightmare. Alright, so I'm using this board holder, and I'm gonna start with this 10 microfarad capacitor. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so let's begin the fun. And how I say that this board is really cheaply made and amplifier costing so expensive, I already ran on that issue. The traces, they are coming off. Will be a nightmare working on this board. Look at this one, how the solder pad come off. Look in here how the trace start to come off. Look at this one as well over here, how they start changing the color, delaminating. I have another one over here, you can see how it's delaminating. This is really not good at all. Also here on the side of the power supply, you can see here, I hope that camera focus better, please camera. How you can see also here how it's changing the color, just hitting a little bit and coming off like crazy. And manufacturer is aware about this one, because do you think it's coincidence that when Vishal contacted the manufacturer to repair the amplifier, they ask $2,000 and they say that they were gonna just exchange the entire board? Because they know which shitty board they use it, right? So let's have a quick comparison between the capacitor which I'm taking off and the one that I'm putting in. That's really weird. I'm measuring between pin 2 and 3, and this one says that there is a capacitor on the other one, and it's a capacitor of 71 microfarads, and it's just 10 microfarad. Let's try again. Let's try again. Maybe I find one with a bit longer legs. Let's see this one. Let's see this one. Let's try again. Between 1 and 3, and I'm measuring definitely between pin 2 and 3. What's going on with these capacitors? Oh, finally I get a measurement between pin 2 and 3. ESR 2 ohms, voltage loss 1.8%, and it says that is 9,900 nanofarads, and it's same, a 10 microfarad capacitor. Let's try another one, maybe this one randomly from all these capacitors which I take them out from this board. And this one measuring ESR 2 ohm, 1.7% voltage lost, and 10 microfarad capacitor. Alright, so let's see whatever we are putting in, right now are this one Nichicon Gold, and let's measure between the same pin 1 and 2 and 3, and let's see what measure these ones. So DSR is saying that is 1.5 ohm, 1.1%, and almost 9,800 nanofarads, so almost 10 microfarads. Let's see between 1 and 2 if it's doing the same measurement. Yeah, 1.4 micro ohm ESR, 1.1%, and 10 microfarad capacitors. So definitely this one are higher on ESR, and we are going with this one. And I think it's time to buy a new component tester also, and I saw one on AliExpress that do also SMD. So yeah, stay tuned for that. All right, so let's insert all the capacitors over there. So our market, where is the positive, which is good. Let's put them in. That one is there. This is positive and this is negative. I need to see what's going on with that hole. Actually, at the end is go through. Let's put the next one. Let me tell you also a secret. When you are dealing with this kind of PCB boards that they are coming off the trace, it's very easy. And if you are lucky, it's a dual layer PCB, you must do this. So here we go. How you can see, I keep the capacitor really high from the PCB, like that. If you see that some points is not soldered correctly, at least you can come from this side slowly with the soldering station and add also from this side a little bit of soldering wire, like that. You are making sure that at least the contact is over there. And also you need then also to go one by one to measure from the leg. Make sure that you are measuring from the leg of the capacitor to the trace where it's going, and make sure there is a continuity. And for tonight I'm gonna leave it like that. I'm gonna come back to it tomorrow evening. For you it's gonna be just a second. So it's the next evening and I still have few capacitor more to change, like this, and this over here. And I feel to leave the board like that how it is, because I never struggle in my life so hard just to change few capacitor on a PCB board. Maybe the manufacturer choose to do this one just to don't be serviced, just to don't be repairable. Who knows? Maybe Louis Rosman, which is the master of right to repair, if he might watch this video, can say the truth. Why this board is so hard to work on. Anyway, if we start, let's finish. So I'm going to take out these two, and these two right now. My desoldering station is ready, so let's get there. So let's put the new capacitor in now. So this is going to take the place of this one, so 100 microfarads, 35 volts. These are 1000 microfarads, 35 volts. They're gonna take the place of those ones. And these one are 2200 100 volts. They are very light, these ones. This one are a bit more heavy, so maybe they dry already, these ones, who knows. And let's put them in. So I'm gonna start with the smallest ones over there. Let's bring the board a bit near. So positive is show me that should stay on the other side. Here we have a problem. The hole is not empty, because that's why I said this board is really badly made. So let's try to put a little bit of solder over there, but let me turn on my soldering station. Let's put a bit of solder over there. And now let's try to sag it out with my soldering station, which I need to wait again because I switch it off. So anyway, let me check the other holes if are okay. This one can be, this one can be, this one can be. So only one hole that, as I say, this board is really badly. I can't believe such expensive amplifier, manufacturer put capacitors or whatever are those ones on the back side, because the place of those one, I believe they should be this C17 and C4 over there, but apparently I believe it was on the wrong traces. Oh, I really don't know. You pay such a money for something and then you receive something that is not what you expected, right? So I believe my desoldering iron reached the temperature. Where is my cleaning tip? Let's make sure also the hole is, sometimes you know this gun is getting stuck over here, so sometimes you need to clean it like that. And let's try again to make the hole of this one. I hope that worked. Let's see now if the capacitor lead can pass. Yes. So let's get the capacitor that I say that they go in that place. So positive is in that side, negative is in this side, like so. And the same also here. Positive is in that side and negative is in this side, and they go like so. I'm gonna keep it a bit rising because I say this is really painful PCB board. So if I might need to retouch from the bottom side, I can stick my soldering iron underneath there and can give a solder, because believe me, it's so bad, this board. So a little solder over there. That solder also to the other pin. Same to this one. And finger crossed that it will gonna have a good solder. Okay, to make sure, maybe I turn around this board. I'm gonna have a look underneath if I can give little touches over there, because as I say, this board is really bad. I never struggled on my life so hard just to solder two capacitors, man. Never ever in my life struggled so hard. Right, this one are fine. Now let's go with the next one, which are the 1035 volts. So this one is telling me that the positive is in there, negative is in this side. Where's the other one? Over here. Positive is in this side, negative is in this side. Also this one, I'm gonna keep them a bit raised that I can stick my soldering iron underneath in case it's not getting a good contact, because only like that I can work what I can do. Next time, McCormack, please use a very good board for your amplifiers, because honestly I'm ordering PCBs from GLC PCB and I can say that are definitely better than what I'm soldering right now over here. Better in everything. Look also what is doing look how it's bubbling the soldering over there. You tell me, which type of the PCB is this one? You tell me, because definitely I never seen bubbling like that the solder, and I'm using only 360 degrees on the soldering iron. Even I'm not using too much temperature to say that maybe I'm using too much high temperature and that's why it's happening what's happening. But no, only 360 degrees. And this one is really bad. This one is really bad. Look, this one is bubbling, like boiling. Look, making bubbles. I never seen in my life such a thing. I never seen in my life such a thing. Right. Let's put those big boys. So it's telling me positive is in that side. So should be snap-ins, and these ones, I hope that they're gonna get good soldered, because otherwise definitely we're gonna have a big issue. I can't put my soldering iron underneath of them because these are snap-in. So let's give a quick solder also on these ones. Look, it's bubbling. How is that possible? Which kind of PCB board is this one? I never seen the solder to bubble like that. Right. 3 plus 3, 6 more. And later on, after I'm gonna change all the capacitor, I'm gonna show you also why I say it's also a bad design and things that for me I considering on this price they should don't miss from the amplifier. Maybe you noticed that I was desoldering one capacitor and then I soldered it back. So let me show you why I did that. Alright, so these are the bipolar capacitors, and the one that I have right here to change it are not bipolar. So definitely I can't change those ones. I'm gonna have a look if I can find bipolars on 1000 microfarad, 16 volts it says. If I'm gonna find bipolars on that value, I'm gonna change them before installing the board inside the chassis, because definitely are bipolars, and here are polarized capacitors. Alright, so I'm going to install these ones. So I have the 22063, so 22063, and the positive is telling me that is in that side. And then I have the 22063, which is this one, and the positive is in that side. Right. Here I can see that I can also keep those one a bit out from the board. Yeah, I can see them if they are not falling down. All right. So I'm gonna say that that height can be alright for me. Let's go, so this one almost the same. As I say, I need to give a touch also from the other side, because the board is really badly. So quick solder to these ones as well. And now I'm gonna have a look if I can find the bipolar on that value. I never seen bipolars on that value. I know that there is like 10 microfarad, 1 microfarad bipolars. But 1000 microfarad bipolar, I never heard yet. Right, so the big ones are 100 volt 470, and 100 volt 470 are these ones. So it's telling me that the positive is right on that side. That one should stay there, and I think I need to hold it by my hand and solder it, because they should be snapped in, but because the hole is too big, they falling down. So if I can hold them a bit and then solder, gonna be nice. Let's put also this one here. The positive is in that side. Hold with the finger on the bottom. I say hold. Well, looks like my hold. Just let it fall down. Should have a third hand, right? That I can pull this. But I can get a little bit just to hook up there. Can give a nice solder on the other pin. Now I can retouch the other pin. And for now, these are all the capacitors that we have to change. Part of this one and this one looks like they are bipolar. So let's see if exists such a thing. Okay, so let's have a look on eBay, because just to order 2 capacitors from Mauser will gonna cost a lot of money, the shipping. So 1000 UF 16 volts bipolar. Let's have a look. Here it's telling me that there is something bipolar. So let's have a look the capacitance. 1000 out of stock. So this is not in stock. Anything bipolar, apart of that one, non-polarized, 1016 volts. Did you ever heard about these capacitors? Nitai, did you ever heard about them? 10 units, 5 pounds. It's really weird. I never heard about those capacitors. But anyway, are not easy to be founded. Most of them are all of them polarized. So only those Nitai that I might can order. And to be honest, it's first time for me to meet this capacitor such high value, 1000 microfarad and bipolar electrolytic. I know, I know I changed before like those 10 microfarads or 1 microfarads, usually those green caps that looks really nice. I never believe it on this one, so that's why when I say which value I need to visual, I didn't notice that are bipolar, because I say such a value, I never think that it will gonna be a bipolar. So I assume it's a bit also my mistake because I don't check before ordering the capacitors. And a few days later I received the bipolar capacitors, are these green ones here, so Arnichicon Muse. It looks really cool, and the board has been nicely cleaned. The soldering at the back, what to do if the PCB is bad, and next step it will gonna be installing everything on the chassis. So why I say that the design is quite bad, I would like to show the schematic, but I'm afraid about copyright infringements because it's very hard to get the schematics of these ones, but I got it from somewhere, but I will not share it because I don't know how works the copyright, but the PCB is here and the PCB is made by manufacturer, so I can explain here a few things how they works. So you have this one. These two are the drivers that will gonna drive the power stage, which I already did it the previous video. I'm gonna put the link on the description down below. And you have the output, which is also here, tied to the output to the speaker that goes there. So then you have this IC over here, because it's such a bad design in this amplifier that very easy this one drift on the output, and it will gonna give you some voltage on the output, so you will gonna have present some DC voltage on the output, because this amplifier, how is the schematic, drift like those cars in Tokyo Drift, same like those cars in Tokyo Drift. And then he used an op-amp as a DC servo schematic, is called it. So practically what this one does, so it's tied to the output and is controlling if it's present, let's see, on the output is fine present positive voltage, we're gonna balance on the negative in order to get rid of that positive, in order to try to keep as much possible to 0 volts on the output. And if this one fail, what happen? You're gonna have a DC voltage present on the speaker. And if you have some 10,000 pounds focal speakers, you're gonna say bye bye speakers, because this amplifier, if that IC will gonna fail, we're gonna burn your speaker. Because here there is a kind of protection, but what this protection does is like muting the input. But even without signal, if this one fail, you're gonna still have DC voltage on the output over there on your speaker. So I did some research because I wanted to understand actually what this circuit over here is doing on this amplifier. So practically it's a circuit that keeps the signal to ground until receive the signal from your preamplifier or from the signal source. And once detects that there is an AC signal, like an audio signal, we're gonna activate this relay and we're gonna let the signal to come inside the amplifier. But this one doesn't offer any protection to the speakers. So that's why I told to Visual, let's install also some speaker protection circuit, because it's better to add a second layer of protection in order that, as I say, if you have a 10,000 pounds speakers like those focal, that there is some more expensive, I sell some focals that also costing 200 something thousand pounds. If you drive this amplifier, those speakers, imagine if, let's see, we're gonna blow up, we're gonna short it to a power transistor, all the 60 volts what is in the rail will gonna end up on those speakers, so there is no any protection on the output to save your speakers. So that's why, stay tuned, please subscribe, activate notification bell, because soon I'm gonna start assembling everything back on the chassis. You're gonna see additional things that I bring to this amplifier to make better, and to make sure that if you listen to expensive speaker, the speakers are protected. And yeah, this circuit is a bit faulty, so I presume one of these I see has a problem. But as I say, this board is just struggling to change a small capacitor like this one. Imagine if I need to desolder and I see a deep 14 or 16. How much is this one? 1, 2, 3, 4, 5, 6, 7. Deep 14, another deep 14, and then another deep 8. I'm gonna struggle, and all the traces will gonna come off. Why he don't design it with sockets that you can easily take out the circuit and put a new one? So I think that he designed this amplifier to can't be repaired and serviced. Definitely. And anyway, I find something that I'm gonna add also on the final assembly that simulate this circuit. So same, keep all the signal to ground. As soon as receive the signal input, audio input signal, we're gonna turn on the input from the ground, and we're gonna send it in the amplifier. So yeah, instead of struggle myself to take out these ones, I'm gonna leave it without power, and I'm gonna add that circuit that, as I say, you're gonna see it on a final assembly. And I'm gonna end up this part of video over here, and if you enjoy it, don't forget to give me double likes, will gonna help me a lot. And if you're new watching my video, don't forget to subscribe, activate notification bell, like that you'll not miss my next videos and my next projects. And if you're interested on the tools and everything what I use daily on my working bench, I have links down below. If you purchase through them, you help me out as well with a bit with my channel. Yeah, and until the next one, guys, have a good day and bye-bye.